Scientists say that the average cumulus cloud weighs around 1.1 million pounds and sits over 6,500 feet above our heads. Drifting on the ever-changing winds, these lumbering behemoths hold precious water that is the lifeblood of our planet. In 340 BC, Aristotle wrote the first known work on clouds and climate, in his book Meteorologica. In this book, he called precipitation from clouds meteors, which is where we get the term meteorology from. It wasn't until almost 2,000 years later in England where Luke Howard did some of the first real scientific studies on clouds, classifying them into three different categories: cirriform, cumuliform, and stratiform. Since then, we've expanded upon these, and there are currently 10 different genuses of clouds. On Earth, the formation of clouds begins when water particles evaporate from rivers, lakes, the ocean, and even plants, and rise due to the fact that water vapor is lighter than the surrounding air. This water vapor then gets pushed even higher with one of the three possible lifting agents: cyclonic, that occurs when warm air rises over a cold front; convective, which occurs when parcels of air rise due to being warmed from the Earth's surface until they cool down; and orographic, which occurs when water vapor comes in contact with a large landmass like a mountain. All three of these agents cause water to rise to its dew point, or the temperature at which air becomes saturated. The water vapor in the saturated air starts to become attracted to one another around small dust particles. As the droplets within the cloud get bigger and denser, the cloud eventually falls, bit by little bit, in the form of rain. And when these particles form, they release their kinetic energy. This in turn warms up the air around the clouds, causing the cloud to rise and pull up more air below it, increasing the size of the cloud. If the clouds get large enough, the energy released can manifest itself in bolts of lightning. If it gets cold enough, these particles may freeze and start to collide with one another, then fall in the form of snowflakes. Earth isn't the only planet that gets clouds. For instance, Mars has been known to get thin clouds of water and ice at its poles, and Venus's atmosphere is full of thick clouds of sulfur dioxide that rain down sulfuric acid instead. The gas giants have cloud formations unique to these humongous planets. Jupiter and Saturn have outer cloud decks composed of ammonia, as well as intermediate haze clouds made of ammonia hydrosulfide, and inner cloud decks composed of water. While Uranus and Neptune have similar cloud structures, their clouds are composed of methane, along with Saturn's moon Titan, which has a full fluid cycle for methane. The role of clouds in regulating weather and climate remains a leading source of uncertainty in projecting global warming. This uncertainty arises because of the delicate balance of processes related to clouds. On the one hand, white clouds reflect the sun's rays and cool the earth. But on the other hand, the energy from the sun that reaches the earth gets reflected back at the clouds in the form of infrared radiation that gets absorbed by the clouds in a process known as the greenhouse effect. One way in which we have tried to harness the power of clouds is by cloud seeding, which is an attempt to change the amount or type of precipitation that falls from clouds by dispersing substances into the air that serve as nuclei for condensation. The most common chemicals used for cloud seeding include silver iodide, potassium iodide, and dry ice. The usual intent is to increase precipitation, but hail and fog suppression are also widely practiced in airports. New research indicates there is a global brightening trend among clouds due to a decrease in sulfate aerosols. This is due to legislation like the Clean Air Act and similar policies among the rest of the industrialized world. As difficult as it is to evaluate the effects of current cloud coverage characteristics on climate change, it is even more problematic to predict the outcome of this change with respect to future cloud patterns and events. So we're just going to have to see what shapes our future clouds are going to take.